we're going to review basic function operations. Remember that functional notation, of course, has f of x and x. X is going to be your x values, and remember, f of x is the same thing as your y coordinates. And go ahead and take a look at the differences. When it is just a single x, it's domain. F of x is always range. X is your input. Of course, f of x equals is your output. That's a pretty important one for what we're going to talk about. Of course, x stands for x coordinates. On the flip side, f of x is your y coordinates. And always remember the independent variable belongs with just a single x, and of course, f of x is the dependent variable. Main thing to remember right here is that f of x is the same thing as y equals. Let's go ahead and review just how function notation is written. So if we took f of negative 2, what we are going to do is just simply plug that into f of x. So we're dropping the letter x, putting in negative 2, and of course when we do our order of operations, we get f of x to equal a 5. And remember the 5 is the y coordinate. And to write that in function notation, it is going to be f of negative 2 equals 5. When you plug in a negative 4, of course, you're going to get an output of a negative 1, and your function notation is going to look f of 4 is negative 1. Same when you plug in a positive 3. When you plug in a positive 3, you get an output of 0, so f of 3 equals 0. Let's go ahead and take a look at what happens when we plug in a number. If you want to follow along in your packet, right there is where I am at. So f of x equals 1 minus x. Here, we're going to substitute a 1 into the function. So notice we drop the letter x, we plug in the input, and solve for our order of operations, and of course we get 0. This time we're going to plug in a 1/4. So be careful when you plug in a 1/4. Make sure you do utilize your order of operations properly. Once we clean up the exponents and do some multiplication, we are left with this addition and subtraction of positive and negative numbers. Please be comfortable with converting common denominators so that you can reach a final answer and go ahead and make sure you box in those answers. So f of 1/4 equals 41/16. You can leave this, actually I prefer that you leave this as an improper. The only time that we're really going to make it a mixed number is if we're graphing. So this is not in the packet, but I just wanted to let you know what's going to happen here when we plug in z minus 2. Again, you're going to do your order of operations. Remember, we are foiling this piece right here. We are not just dumping in a 2 to the z and the negative 2. You have to perform the correct operations and multiply out that binomial. And when we combine like terms, we get f of z minus 2 equals, or is, negative z squared plus 6z minus 11. Part 2, composite functions. For your composite functions, before I begin, I'm going to do some work in the packet. I'm going to do a couple of things outside of the packet also. We're going to do about 4 examples here. So what is a composite function? A composite function is where the output of one function becomes the input of another. That is composite functions in the most basic form. So you're going to see a new little symbol. Do not confuse that with a multiplication dot. That is not a multiplication dot. That stands for composition. Given functions f and g, the composition would read as follows. Find the output of f after or by using the output of g. So what we're going to do is we're going to kind of work backwards according to the way this looks. We're going to find the output of g first, and then once we find the output of g, it is going to become the input of f for us to get our final output of this composition. Remember, f of x with function notation here, that is the output. F of x always equals the output. X, just simple x, is the input. So another way to write f of g is to use the output of g as an input of f using this function notation here. Just remember that this and this mean the same exact thing. All right, here we go with our first example. It is going to be composition of sets. Given two functions f and g, you can find f of g and g of f in the range of each is a subset of the domain of the other function. If this condition is not met, the function is not defined, meaning for f of g, the second coordinate of g must match with the first coordinate in f. This is example 1 in your packet. I believe we are on page 14. No, yes, page 14. Those are a lot of words, so we're going to break this down and we are going to go old school all the way back to 7th grade or even 6th grade mapping of functions. So basically, let's start with g of f. So remember, we're going to find the output of f, plug it back into g, and get a final output all over again. We're going to see if it exists. So what we're going to do is we are going to do a mapping diagram. So what I have done is I've taken that set right there and I've written the domain in order and the range in order. And then I did a mapping diagram that matches each output to its corresponding input. So now that we have this mapping, let's go ahead and do the composition of these sets. So our output right here is actually going to turn into the input of G. And what I have done is I have matched each input here to the output according to this set. So here's how we get our final answers for our sets here for our ordered pairs. We look at how the lines are drawn from the beginning to the end. So we started with a 2 here. Remember the 2 was mapped to the 4. But remember the 4 turned into the brand new input of G. And the 4, according to this up here, was mapped to a 5. So our composition of G of f is going to be 2, 5. For the next set, we started with a 4. We mapped it to a 6, but when that 6 became the domain, it was mapped to a 5. So there's our brand new ordered pair. Again, 6 mapped to 8, but then of course 8 turned around and mapped to 12. And then our last, you can see, turns into an ordered pair of 8, 12. So we just did G of f. Let's see if a composition of f of g exists. So we took the input of g right here, and I did go ahead and keep it in order. And here is the output of g according to the 5s and the 12s. But the same thing, we're going to turn this around and make it an input of f. Now, if you notice, there's not any 5 or 12 for the input of f. So this does not exist. So remember, if you do not have mapping that would be the input of the function, then simply it is just not going to exist. There is not going to be a composition for f of